Welcome everyone. Guys, in this session, I will be talking about stability constant, Kstab. We will cover all points required for Cambridge by Cambridge syllabus. And then we're going to solve, the next part of the video, we're going to solve past paper questions, the most recent past paper questions. So before we start, guys, let me remind you about something. When we have A plus B, give us C plus D. So you know, guys, this reaction is in equilibrium. And whenever we have equilibrium, we have what, guys? What do you think? Whenever we have equilibrium, we have what? Any idea? We have what? K, right? Whenever we have equilibrium, we have K. So K, guys, always is the concentration of products over the concentration of reactants, okay? The same idea we will apply here. Let me remind you about the equation we took before. So when we have, for example, when we have Cu H2O by 6, copper complex plus 2, plus 4Cl minus, this will give us, guys, Cu Cl4 negative 2 plus 6 H2O. We took this reaction before. Do you know what we call this reaction? It's
ligand substitution.
yes, amazing. Ligand substitution reaction. So guys, look, we can, because this reaction is in equilibrium, we can write a K for it. So the K here, it is called Kstab. The Kstab, guys, will be the products over reactants. The products over reactants. In the products, we have Cu, Cl4, minus 2, right? Yes. Guys, look, whenever you have water, we don't include it in equilibrium at all. Water and solids. Water and solids, they are never included in equilibrium at all. So water, we don't write it here. Down below, we have the copper complex. Here, water is in a complex. And we have Cl minus. But how many mole of Cl minus? 4 moles. That's why we will raise this one to the power of 4. And this is, guys, the correct equilibrium expression for this ligand substitution reaction. Let me show you now a past paper question. This is, guys, 2022. They give you, or they gave you this reaction, nickel complex, nickel H2O by 6. This is raised to plus 2, plus 3 in. Do you remember, guys, this one? It was the bidentate ligand, if you remember it. En, yeah. So what will happen is En by 3 plus 2, we get this ligand, this complex, sorry, plus 6 H2O. Usually such a question always has 1 mark, and you will be asked about it in each paper. Any paper, when you open it, you will find such a question. So Kstab in this scenario will be the products of reactants. The products, guys, we have nickel, En by 3 plus 2, never include water, over En will be raised to the power of 3 because we have 3 of it, 3 moles, multiplied by nickel H2O by 6. And this one, guys, has a charge of plus 2. This is the correct expression. Okay, we have a question here. Right. Sometimes, guys, you are asked to find the units. So how are we supposed to find the units? Okay, the units of K stability. As we did in AS level, we just substitute any concentration we have by what? By what?
By the power?
No, by what? By mole over decimeter cubic, right? Very simple, yeah. So Kstab, in this scenario, to find its unit, here we will have mole over decimeter cubic. Here we have mole over decimeter cubic. to the power of 3 multiplied by mole over decimeter cubic. We remove this one with this one, right or not? Yeah. And we will end up with mole minus 3 dm or dm9. This is the correct unit. As simple as that. When you are asked about the unit, usually 1 mark, you just put, instead of each concentration, mole over decimeter cubic. So guys, simply, how can we define Kstab? How can we define it? Any idea?
The solubility of.
What do you think, Emil? I will give you now, guys. You are going right now to write with me the past paper definition. So this is the most reliable definition. So it is the equilibrium constant. It is the equilibrium constant. It is the equilibrium constant for the formation of. For the formation of. It is equilibrium constant for the formation of the complex ion in a solvent from its constituents, ions or molecules, ions or molecules. Now, guys, I will give you some important notes. By these notes, guys, you can solve any question related to K stability or equilibrium stability constant. The first note, guys, stability constant, values are expressed on a log 10 scale. Okay. And when we do so, we don't include the unit. We don't include the unit. In any question, when you are given the Kstab value, you will be given like it's 1.2 times 10 to the power of 9. You don't have unit, okay? We don't have unit. Another important note, guys, this note you have to underline it. This is very important note. It says that larger Kstab value, the more stable the complex is. Okay, you have to write, guys, with me now, because later on we will need all of these notes when we start solving the past papers. Right. So the larger the Kstab, the more stable the complex is. And now another note, guys. Each complex has a unique Kstab value. We get it by adding its ligands to water. What do you mean by ligands, guys?
I think it's ligands to what?
To water. What do you mean by ligands? Any idea?
Yeah, we took that.
Yeah, so things that donate lone pair of electrons to make a dative covalent bond with transition element. So guys, for example, we have here this, wait, NiEN 3 H2O or 6 H2O actually. So Kstab for this one is 6.76 times 10 to the power of 17. So as you see here, guys, we don't include any unit when we write the Kstab value. And to measure the K stability of this complex, we are adding the ligands of the complex toward the solution, toward the aqueous solution. To measure Kstab value of this complex, we are adding the ligands to the water, to the aqueous solution of nickel. Okay, guys, this is very important. The larger this number is, then the complex what?
More stable.
More stable. Another note. This is, guys, the last note before we start to solve another question. The note says, we use these numbers. We use these values to compare which complex is more stable and which reaction lies more to right, comma, the larger Kstab, more stable complex and reaction lies more to right. Guys, once you understand these notes, everything will be a piece of cake, okay? Yeah, all the questions related to these notes. So let's see now a question belong to this note. Take a look in here. We have two reactions and we want to measure their K stability value. So as you see, we have aqueous solution of nickel and we are adding to it in, we have this complex and K stability value is given here. Another reaction, we have nickel and we are adding to it Tn. What is Tn? I don't know. Is it bidentate, monodentate, polydentate? What do you think?
Bidentate.
Bidentate because the reaction here is similar to this reaction. So it is bidentate because we have three of it. It's like in exactly. Now, guys, the Kstab for it is this. The first part of the question, they need K stability for this reaction. We did this one a few minutes ago. Now the second question. Describe what the Kstab value indicate about the position of equilibrium for equilibrium 1 and 2. Use the Kstab values to deduce which complex, this one or this one, is more stable. Think about it. Which complex is more stable and why?
One
The second.
has a larger value.
Amazing. So guys, look, the first part of the question, you have to pay attention. If you just say this one is more stable, for example, you will not get the mark. The first part of the question, describe what Kstab value indicate about the position of equilibrium. So
It's to the right.
amazing. Yes, to the right. So the direction of the equilibrium shifts more to the right, okay? Because guys, look, all of these numbers are large numbers. And in Kstab, we divide what? The concentration of a product over reactant. That's why when we get large number, that means we have so many concentration of a product. So the direction of from Kstab, we understand that both reactions and both equilibriums, the direction of the reaction goes more to the left, to the right, sorry. And this complex is more stable as it has larger Kstab value. That's it, we're done. We get the 1 mark. Okay, guys. And by the way, here they need the units. We did this one also. Now we have some two notes, another 2 notes, and then we can start the solving the rest of the past papers. Guys, look. Bidentate ligands such as in have higher Kstab value than monodentate. Okay. This is the first note. A second note, guys, it will be, or it says, we use Kstab values to predict whether ligand substitution reaction occur or not. We will use Kstab values to see if the reaction occur or not. Okay, let me give you a question here. If we add excess ammonia to solution has CuCl4 minus 2 complex, will we have ligand substitution reaction? Here, guys, I have CuCl4. And to this solution, we are adding what? NH3. Will we have ligand substitution reaction? Guys, look. To answer this question, you need to take a look on Kstab values. Kstab values. Let me show you now something. This is the table, guys. You'll find it in your book. We see that if we have the Cl as ligand, the Kstab is this. And if we have NH3 as ligand, the Kstab is this. So guys, what do you think? Will we have ligand substitution reaction or not?
I think so.
We do so. We will have. Do you know why? Because, guys, the complex with NH3 will have more stability. It has more Kstab. That's why ligand substitution reaction takes place. Okay? This is very important, guys. Let me say that 40% of the questions about this topic. We have to see which one or which ligand will give me a complex with more Kstab. Then I can judge whether a substitution reaction occur or not. Yes, Amal, say.
So if the chloride had higher than ammonia or ammonia had lower,
no reaction.
It wouldn't occur?
No reaction, no.
So
No.
what's added to the complex has to have a higher K stability than the complex.
Yes. This is similar to the topic of E values, but here we don't have E values. Here we have K stab values. Let me change the question. Now, I have, guys, a solution that has a complex, let me say, Cu, and the ligand was this. I will call it Te, or I will call it DH. Up to me. Call it anything. And to this one, we are adding NH3. Will ligand substitution reaction take place? No, it will never. Wait, let me ask you another question. Why this one, guys? Oh, sorry. Why this one has relatively larger value than ammonia and the chloride?
Because it has more OH atoms, so it's more soluble in water.
No. Why? Bidentate. It is bidentate. It uses this O and this O to make two bonds. So it is bidentate. Bidentate always have higher K stab than mono. These are mono. Okay? Always bidentate have larger value. So look, guys, to this reaction. Here we have important reaction. This is the reaction I show you. We had a solution that has a copper complex with ammonia. To it, we added this ligand, the one with bidentate, the one that is bidentate ligand. What will happen is we have ligand substitution reaction. Why? Because this, guys, the complex that we made here is more stable. Okay? Guys, look, now you don't need to read the book. You don't have to see anything. Just now you can start solving any paper. Welcome, everyone. So in this part of the video, we'll be solving the questions related to, or past paper questions related to Kstab topic. So the first question we are going to solve is this. Silver bromide AgBr dissolves in aqueous solution of S2O3 minus 2 ions to form the complex ion. We made this ion. Guys, by the way, Ag complexes are always linear, okay? It always binds to two monodentate ligands. Yeah, and this 2O3 is monodentate. It's also given here. So we have this equilibrium. We have this equilibrium in here. Right. The question related to our topic, write expression for equilibrium constant Kc for equilibrium 1. So guys, equilibrium 1 is here, and we need to write the K expression for it. Whenever we have K, we have concentration of products over concentration of reactants. So on the products, we have Ag S2O3 by 2 multiplied by the concentration of Br minus over S2O3 charge minus 2. This one is raised to the power of 2 because we have 2 moles of it. Guys, look, AgBr is solid. So its concentration is treated as constant. Guys, we don't include it in K expressions. Solids and water, as I said, we don't include them in K expressions. So this is, guys, the correct form of K. I will keep it because we will be in need for this one in the next questions. Okay. So let's continue, just 1 second. Oh, right, okay. Some additional data are given about the dissolution of AgBr and S2O3 minus 2. We have the solubility product here is given, and we have a stability constant here is given. Look, guys, before starting with reading the question, I hope you stop the video and try to solve this one out. It's kind of hard, but we will try. Before I start solving it, let me show you something. Here we have the solubility product KSP. How can we write expression for this one? We know that, guys, the expression for this one is KSP equal to concentration of Ag plus times the concentration of Br minus. Guys, look, this Ag plus here is aqueous. It's found in water. Why this is important? When we start solving the question, I will remind you why this one is important. So remember, this one is aqueous. This Ag plus is found in water. When Ag plus is found in water, so we have something, guys. I will remind you about this thing. Now, Kstab, we have another stability constant, which is Kstab. Kstab for this one, guys, is AgS2O3 by 2 on this. So how can we write Kstab equation for this one? How can we write Kstab equation for this one? The equation, how can we write the equation? Look, guys, whenever we have Kstab, that means the original complex was found in water. Let me remind you, whenever we have Kstab, that means the original complex was found in water. So look, that means Ag H2O by 2 plus 1. This one was found in water. To it, we are adding what? S2O3 minus 2. And then we will get this. We will get this complex in here, a plus 2 water molecules. Okay? This is, guys, how the Kstab reaction is written. This is how can we write Kstab reaction. Right. Now we need to write Kstab. What? Kstab expression. So how do we write Kstab expression? We will say this complex AgS2O3 minus 2. Okay. Sorry, this one minus 3. Yeah. Minus 3 here, which is the product. H2O, we don't include it. Over the reactant, which is S2O3 minus 2. And here we have also Ag H2O by 2 plus 1. Before we start solving this question, guys, I will write another thing and then I start solving it. I know, guys, this is very hard question. I started with one of the hardest questions. And this is, guys, one of the most common questions that start coming recently in Cambridge papers. So let me, before I start solving the question, let me remind you about the original Kc that we wrote in the previous question. So my Kc that we wrote, it was Ag S2 O3 by 2 minus 3 Br minus over S2O3 minus 2 to the power of 2. This is the original Kc, okay? Now, guys, I'm going to show you why I need this. Look what the question says. Use the answer to CII, this answer they need, and the data, these two data, to calculate Kc for equilibrium 1. They need Kc value. You are given these two things, and you are asked to calculate Kc value. What is the Kc value? So guys, what am I supposed to use? What am I supposed to do with these two numbers? Should I multiply them? Should I divide them? But divide what? Divide this one by this one? Or divide this one by this one? Divide what exactly? How am I supposed to know if I should I multiply? Should I divide? What am I supposed to do? To know what we are supposed to do, guys, we will use these two equations here. This equation, or this equilibrium and this equilibrium equation. I will use these two equations, okay? I will try either multiply this one by this one, or either divide this one by this one, or either divide this one by this one. To what? To get this equation. So how am I supposed to get the original equation? Am I supposed to multiply these two things? Am I supposed to divide them by each other? So look, guys, I will start with multiplying them. I will multiply this by this. So let me just write these two things here. AG plus, this one will be multiplied by AG plus and BR minus. So look, guys, AG plus will be cancelled with this one. Opa, you tell me now, teacher, we have here two water molecules. This is a complex. So how am I supposed to cancel them? Why did I cancel them? I will remind you. Guys, here Ag is a +1. So it is found in where? It is found in water. So in water, it makes complex. Whenever we write Ag plus, that means we have Ag plus H2O by 2. It's a complex. Look, guys, any ion, any positive ion, Cu plus 2, Fe plus 3, Fe plus 2, all of these ions in water, they make complexes. We don't write H2O for short. H2O by 6, H2O by 2. We don't write them for short, but actually all of them are complexes. So this complex will be cancelled with this complex. And Br minus will be multiplied by this one over this S2O3 minus 2. We end up with Kc. The equation we get is similar to Kc. So I will what? I will multiply these two numbers to get Kc value. Okay, guys? So whenever you are given more than K values, and you are asked to calculate a certain K from these Ks, you are supposed to multiply them or divide them. How do you know? You try this one out. You try to multiply their equations by each other until you get the original equation of that specific case. If multiplication doesn't work, you use division. You divide one by one, or you divide this one by this one, or this one by this one, until you get similar equation to this. Don't worry, we have a similar question here. The last one we will solve. Guys, this equation is quite complicated. I am telling you, this is the hardest thing that you're going to ask, that you will be asked about. Right. They need the unit also of Kc. The unit, guys, is quite clear. This one is mole over decimeter cubic. This one will be mole over decimeter cubic. This one, mole over decimeter cubic, but to the power of 2. So all of these are cancelled. Guys, here we have unit of 1 or no units. Okay? I hope, guys, now you are following what am I talking about. طيب. So we are moving now to the next part of the question. I will erase all of this. Yeah. The numerical value of K stability of two other silver complexes are given. Don't forget, before we have a value of another silver complex, which is this, okay? An aqueous solution containing Ag plus is added to solution containing equal concentration of Cn and NH3 and S2O3. Okay, the mixture is left to reach equilibrium. Nice. Deduce the relative concentration of this one, and this one present in the resulting mixture. Explain your answer. Which one has the highest concentration? Which one has the lowest concentration, and why? How are we supposed to know, guys? Look, whenever we are asked about concentration, guys, we need to see Kstab values. That's why, guys, in the previous notes, I told you these notes were very important. We will use Kstab values to figure out whether we have high concentration or low concentration. So let's see. In here, guys, we have the highest Kstab value. It is for AgCN by 2. So because this one, guys, has the highest Kstab, it will be the highest concentration. The lowest concentration, it will be for this one. And the moderate concentration, guys, it will be for this one. So here we get 1 mark. The question worth 2 marks. Another mark, guys, will be for the reason. We say that AgCN by 2 minus, this complex has the largest Kstab value, okay? So this complex is the most stable and the one that will be made in huge concentration. And this one has this lowest Kstab value. This complex has this stability and it will be the least concentration that will be made. Okay, guys, what was this paper? The questions are over now. This is, guys, May, June 2021. Right. And the paper, guys, the question is over. Let's move to a different paper. What is this? This is 2021, October, November. Let's see the question. Excess aqueous ammonia is added to solution containing this complex. So we have this complex, we are adding 6 NH3s, we get this. Right expression. Guys, this is one of the most common questions and the easiest questions actually. So we have cobalt NH3 by 6 plus 2 over NH3 to the power of 6 because we have 6 moles, cobalt H2O by 6 plus 2. Ignore the water, we don't include it at all, okay? Okay. Let me erase. The numerical value of Kstab of cobalt NH3 by 6 plus 2 is this number. Okay, is this number. What deduction about the properties of this one and this one can be made about this value? So as you see here, guys, we are comparing between the water complex, we are comparing between the water complex and the NH3 complex with NH3 as a ligand. And guys, here we have the Kstab value. And as we see, guys, in the previous part that I made here, we divided the concentration of this guy over the concentration of these things here. And we get very large number. If you divide the concentrations, you end up with this number, okay? So it's a huge number, bigger number. That means we have here a huge, higher concentration. So how do we say this, okay? We say that this complex is more stable. That's why, guys, it's made in a huge concentration. Okay, that's why it has huge concentration, more concentration than cobalt H2 by 6. Okay, so this complex is more stable, and the reaction lies more, this reaction, guys, lies more to the right side to make this stable concentration. Sorry, to make this a stable complex. I hope, guys, this is clear for you. So yeah, the question about Kstab here is over. We are moving, guys, to a different question. Okay, this is a question kind of simple. A solution is made by dissolving CuSO4 hydrated copper sulfate in excess aqueous ammonia. We are adding this one to ammonium solution. Sorry, to solution has ammonia. This solution contains the copper complex. We have this copper complex, so we don't have water in it. Okay, no problem. Write Kstab of this. Guys, look, to write Kstab, we are supposed to have an equation, right? Equilibrium equation. But here the equation is not given. We are supposed, guys, now to find the equation, to write the equation by ourselves. So how we are supposed to do so? How can we write the equation? Let me show you something. Whenever we have Kstab, that means the transition metal or the metal was dissolved inside water. Okay, it was found inside the water. You know, guys, copper in water is CuH2O by 6. Charge is a +2. Plus how many ammonia? Plus 4 ammonia, because in my product we have 4 ammonia molecules. So 4 NH3 equilibrium. We will get what? We will get, guys, CuNH3 by 4. And this one is a +2, yeah? Plus 6 water molecules. Okay? Now we can write easily the Kstab. So we bring the concentration of this guy, put it here. The concentration of this guy, put it down. The NH3 guy's concentration will be raised to the power of, 4. Will be raised to the power of 4. That's it. This is the question, the only question we have in this paper, which is what? Which is 2020, October, November. We are moving to a different question now. Question 5E. Okay. This question, guys, we have the stability constant Kstab of 3 complexes are given in table. So here we have this complex, 3 complexes and their Kstab values. Which one is the most stable? Which one is the most that will be made? Is this one, because it has the highest Kstab value. This one, guys, is the least stable due to its Kstab value. I hope now, guys, you are familiar with this. Write an expression for Kstab of this one. Another type, guys, the previous question we solved is exactly similar to this. But here we have one difference. The difference is, guys, I don't know Hg in water. What is the shape of Hg in water? In the previous question, we took that H2O, when we put it inside water, it okay, guys, now we are on question 5. Let's take a look on question 5. 5E. The stability constant of 3 complexes of mercury are given in the table. So here we have 3 complexes. Guys, this complex, this one will be the most stable one, okay? This one, guys, will be the most stable. How do I know? I know from this, the concentration of it. And this one, guys, will be the least stable complex due to its low concentration. When you are given, guys, such values, that means 100% the question guys, that you will be asked about is about making comparison between these three complexes, as we will see in the next part of the question. So the first part, write expression for Kstab of HgCN4 minus 2, this complex, sorry. Opa. So guys, look, this equation is similar to a question we solved before. Here also we don't have equation, but we have one problem. In the previous equation we solved CuH2O by 6. This one, guys, we have it in the book. We know this one from the book. This complex, we know it from the book. But what about Hg? We have Kstab, so the reaction part will be the ligands that we are adding, which is 4 ligands, because we have 4 of this, plus the complex, okay, the complex of the metal. So what is the complex of the metal in here, guys, in this scenario? Okay, this is the question we should answer. Look, guys, now, when we see here, we don't have any idea or any clue about the complex of Hg in water, how it should be like, how many water ligands should we have. So in this scenario, guys, and this is not required to know how many, we can write only Hg plus 2 because we don't know, guys, how many water molecules should be combined with Hg when we make a complex. Equilibrium reaction, we will get the complex HgCN4, and here we have minus 2. Okay, now guys, Kstab will be quite easy. We will divide the product over the reactants. Don't forget Cn minus, guys, will be raised to the power of 4 because we have 4 moles of them. And this is, guys, the first part of the question. Moving to the next part, aqueous solution of Hg plus 2, we have Hg plus 2 aqueous, AQ, is added to solution containing equal concentration of this one, and this one. Okay, we have a solution that has I minus, Cn minus, and Cl minus. We are adding to them Hg plus 2. Predict which of the complexes, this one, or this one, or this one, is present in the resulting mixture in the highest concentration, and which one is the lowest concentration. Explain your answer. Guys, we go immediately to where? To this one, guys. We go immediately to this table. We see, as I told you before, this one, guys, has the highest Kstab value. So this one will be the complex that will be made in the highest concentration. And this one will be the one that is made in the lowest concentration. So here we get 1 mark. The second mark, guys, will be given for the reason. We say that Kstab value, or this complex has the highest Kstab value, while this complex has the lowest K stability value. And this is, guys, how do we answer such a question? Okay? Yeah. So now, guys, we are moving to the last question we have. This question, guys, is very important, and it is similar to the hard question we solved before. Both of them have the same idea. Guys, the paper here is 2020, May, June. Okay? The first question was about the inorganic part. Here we have explanation or definition. It's not important for us. We need Kstab values. Questions about Kstab. So, yeah, let's see. When a solution containing EDTA, this is a polydentate ligand, adds it to solution containing this. Here we have this equilibrium, guys, is Kstab. How do we know? We know because the transition metal or the metal was in water, in aqueous solution, and to it we added EDTA. Okay? Here we have ligand substitution reaction. Circle on the structure of EDTA the 6 Actually, this one doesn't belong to our, where is our question? Yeah, here we have a question about Kstab. I don't want to make the video long, guys. We need to solve just the questions of Kstab. So here, guys, write the expression for the solubility Kstab for equilibrium 1. So here we have to write the expression. How we are supposed to do so? So Kstab equal to concentration of this, we write this here, over the concentration of EDTA multiplied by this concentration. And guys, in this way, we solve the question correctly. We get 1 mark. We continue. So guys, I hope that Kstab topic start to be easy for you. طيب. Look guys, this is one of the hardest question. It's quite hard, really hard. And I hope guys here you stop the video and watch it, keep thinking about it, try to solve it as we did in the question that was here in this paper. And then you start the video again. Anyway, cadmium ions form complexes with methylamine and 1,2-diaminoethane, this one, as shown in equilibrium 2 and 3. Okay, here we have equilibrium 2 and here we have equilibrium 3. So look guys, what am I supposed to do before starting to do anything? If you try to solve the question, you might know that we have to find equilibrium 2 and equilibrium 3 equations, as we did in this paper, before I start with the question. So I will write the equilibrium 2 and equilibrium 3 equations, okay? So just 1 second, let's just make this one smaller, like this, yes. So we have enough space. Guys, Kstab 2, it's calculated. Or let's write the equilibrium expression for it. We will have this one, CD, CH3, NH2 by 4, H2O by 2, and all of this to the charge plus 2, over what? Over CH3, NH2 by what? Or to the power, sorry, of 4 times this one, CD, H2O by 6. So this is, guys, the first Kstab. Here we have another Kstab, which is this one. So this one, guys, it will be what? How do we write it? It will be CD, En by 2, right? And H2O by 2 plus 2. Here we have En to the power of 2. And guys, also we have the CD H2O by 6 plus 2. So I wrote them and I will tell you why did I do so. Here we have another equilibrium. How do we get this equilibrium? An equilibrium is set up between these two complexes as it is shown. What did they do here, for God's sake? Yeah, we are adding 2En, which is, yeah, we're adding 2En to this one, and we get this. Guys, do we have here Kstab? It is not Kstab. It is not any type of case we took before. They wrote it K equilibrium because if this one was Kstab or stability constant, this one should be in water only, not ethylamine and water. Sorry, not methylamine and water. Okay, so the K equilibrium 4 is the equilibrium constant for equilibrium 4. Write expression for K4 in terms of Kstab 2 and Kstab 3. So the question is, look guys, what's the question? They need expression for K equilibrium 4 for Kstab 2 and Kstab 3. should we say that K stab 2 times K stab 3 will equal to K stab 4? Sorry, K equilibrium 4? Or should we divide them? Should we divide this one by this one? Or this one by this one? How are we supposed to know? Guys, I hope you remember what did we do here. We will do exactly the same. Before I do the same, guys, look. Before I do the same, let me show you something here. Wait. Let me show you something here. Equilibrium for, let's write the K equilibrium for it. K equilibrium, how it will be? It will be CH3 NH2 to the power of 4, right? And CdEn2, CdEn2 H2O by 2, right? Plus 2 here. This one over this very long thing, I don't have time to write it, multiplied by En to the power of 2. Guys, look, I need a way in which if I multiplied this equation by this equation, or if I divide this one by this one, this one by this one, or this one by this one, to get the same thing. So how can I use these two equations, division, multiplication, to get the same thing? Okay, how can I use these two equations to get the same equation as this? What we are supposed to do? Think about it, guys. Guys, as you see here, guys, as you see here, in the and up here, we have CH3NH2 to the power of 4, and we have this complex. Okay. So, and here down we have En by 2. Down here we have En by 2. So how can we get such thing? By doing what? By doing what? Okay. So let's guys try to divide. Let's try to divide K stab 3 by K stab 2. Dividing K stab 3 by K stab 2. Here, guys, multiplication is very hard. Not very hard, but it will never give me anything. Do you know why? If you multiply them, you will get, in the here down, we have CdH2O by 6. So if you multiply this guy by this guy, you have this one square. And here we don't have the cadmium in water at all. So it must be division. But dividing what by what? I will divide stab 3 by stab 2. So if I divide them, will I get the same thing in here? Let's see. If divided 3 by 2. So we will have this one, guys, will be in the top. I will not write them, but just show you. This one will be on the top. And this one, guys, comes to the bottom. Okay, this one will come to the bottom. So in here, yeah, En by 2, H2O, yeah. This one will come to the bottom. Let me draw them with the black. Where we have this very long complex, this one, I will not write it, just write this. Over, here what do we have? CH3 NH2 by what? Oh, sorry, to the power of 4. And what do we have also? CdH2O by 6. Guys, CdH2O by 6 will be cancelled with this. CdH2O by 6, they are cancelled. And what will happen also, guys, this one, if you know in math, when you have such thing, this one, guys, will goes up here, will be multiplied here. Okay, so CH3 NH2 to the power of 4, right? Yeah, to the power of 4 will be multiplied by this one, which is CdEm by 2 H2O by 2, the same. Okay, so this is so as I said, guys, now in the numerator, we have these things here, which is similar if we divide K star 3 by 2. And the guys in denominator, we will have En to the power of 2. Okay, here. And here, guys, we will also have this one down. Okay, we will have this one down. And what also we have down? We have this long one, this very long complex, giant complex here down. Also, we have it in this complex. And in here, guys, in this part, this complex will be multiplied by En. I know, guys, it's very complicated now. It seems very complicated. But if I write all of this, the video will be too long. I hope, guys, you know what did I do. So if you just try to make it an organized way in your copybook, you will end up, if you divide K star 3 by 2, you end up with this thing exactly. Okay? You end up with this thing. So the correct answer here is dividing K star 3 by 2. If it doesn't work, divide 2 by 3. If it doesn't work, you should multiply them. Okay? So the two equilibrium constant here, the K star 3 and 4, sorry, 2 and 3, they should be equal after do something for them, multiplication or division. They should be similar to the equation here. We solved two equations similar to this, guys. I hope you revise them. This is one of the hardest and one of the, let me say, it takes very long time, but really you can't do it easily after watching these questions. And thank you for watching, guys.